In this video, I will continue pipe networking numerical equivalent pipe. The question is a pipe of diameter 20 cm and length 2000 meter connects two reservoirs having difference of water level as 20 meter. Determine discharge through pipe. If additional pipe of diameter 20 cm and length 200 meter is attached to the last 200 meter length of existing pipe, find increase in discharge, calculate minor loss, and take frictional factor of is equal to 0.06. So there is two cases. One is single pipe which diameter is 20 centimeter, that is 0.2 meter, and length is 2000 meter. And these two reservoirs have water level difference in water level 20 meter, which is also called head loss HF. So this is first reservoir, this is second reservoir. So this is pipe. We have given difference of water level between these two reservoirs as 20 meter. So this is point A, this is C. So we know head loss formula is 8 FL Q square upon pi square G d raised to power 5. F is frictional factor 0.06, length is 2000 meter, discharge is unknown, and G is 9.81, and diameter is 0.2. So we got value of discharge Q1 in this pipe AC 0.0254 meter cube per second. And another case is there is additional pipe of length 1200 meter attached to last 1200 meter of existing pipe in parallel. So we have to neglect minor losses. So this is a figure of case 2. This is existing pipe and this is one parallel pipe of length 1200 meter and diameter 20 centimeter, that is 0.2 meter. So in question it is given we have to neglect minor loss. That means loss in bend, entry loss, exit loss, etc. So RA is 8 FL upon pi square G d power 5. F is 0.06 in all three cases, and G is 9.81. Length of AB, since this is 2000, from here to here 2000, and from here to here it is 1200. So this is 2000 minus 1200, that is 800, and pipe diameter is 20 centimeter for all, that is 0.2 meter. And this two length is both same 1200, so we got these three value. And equivalent are equivalent for parallel pipes BC. This is BC and this is BD. It's given by this formula is in parallel condition. So 1 by R equivalent is unknown, RBD and RBC is taken from here. So value of R equivalent is 4647.761. So this is A, this is B, this is C, and this is D. And so head loss from here to here is head loss AB plus head loss of equivalence of these two parallel pipe. So head loss is given by RQ square and equivalent head loss is given by R equivalent Q square. Q2 is discharge in this case 2, second case. So HCF is given in question, that is 20 meter. RAB and R equivalent is we have calculated. So from here Q2 is 0.0343 meter cube per second. Increase in distance. So by connecting this pipe, we got the value of Q2 higher than Q1. So increase in distance is Q2 minus Q1. Q2 is 0.0343 and Q1 we have already calculated when there is only single pipe, that's 0.0254. So increase in distance is 0.0089 meter cube per second. So this is similar question. A pipe of diameter 1200 millimeter and length 3000 meter. Diameter is 200, that is 0.2 meter, and length is 3000 meter. Connects to reservoir. So this is reservoir 1, this is second reservoir, having difference in elevation 50 meter. From here to here it is 50 meter. So difference of water level is 50 meter, which is also equal to F. So 50 meter. If an additional pipe of diameter, so we have to first calculate discharge in this condition by this formula. So discharge is 0.0568 meter cube per second. If an additional pipe of so this is 50 meter here. This is A, this is C. So case second, if an additional pipe of diameter 300 millimeter, that is 0.3 meter, and length 1200 meter is attached to last 1200 length of existing pipe, find the increase is discharge. That means we have to calculate Q2 minus Q1. Q1 we have already calculated, so we need to find Q2. Since F is 0.02, so in F 0.02, and length of AB is 1800 because it is 3000 minus 1200, and length of BD is 1200, and diameter is 300 millimeter, that is 0.3 meter or 30 centimeter, that is 0.3 meter. Similarly, we can calculate RBC, which length of BC is 1200 and diameter is 0.2. So equivalent, R equivalent for pipe BC and BD parallel pipe is given by this formula. So R equivalent, we got this. So this is first reservoir, this is second reservoir, and this length is 3000. So 200 meter, 1200 meter is length of this pipe, and last 1200 meter. So from here to here it is also 1200 meter. So equivalent for parallel pipes, this is BC and this is BD. So equivalent of these two pipe is given by REQ. A, B, C, D. BC is one pipe and BD is additional pipe. So combined head loss is head loss in AB and head loss in this two pipe. So HG of AB is RAB Q2 square and HG of EQ is REQ Q2 square. HG of value is 50 meter. So 50 equals RAB and REQ we have already calculated. So Q2 is 0.0717. So we need to find increase in discharge is Q2 minus Q1. So increase in discharge is 0.0149 meter cube per second. So this is another question. A pipeline of 0.6 meter diameter is 1.5 kilometer long. To increase the discharge, another line of same diameter is introduced parallel to the first in the second half of the length, neglecting minor losses. Find the increase in discharge. Friction factor F is 0.04. The head at inlet is 300 mm. So this is case first. This is A, this is C. So head at inlet is A. So head at A is 300 meter, that is 0.3 meter. So in first case we have to calculate Q1. So direction is here. In first case diameter is 0.6 meter, length of pipe is 1.5 kilometer, that is 1500 meter. Head at inlet, that means head at A is 0.3 meter. Head at outlet is, since outlet is open to atmosphere, so pressure head is 0. Head loss is inlet head minus outlet head, that is 0.3 minus 0 gives 0.3 meter. So by using this formula we can calculate Q1. Head loss is 0.3 meter, F is 0.04, length of this AC is 1500, Q1 we have to calculate, and diameter is 0.6. So in second case, length of attentional pipe, the total length of pipe is 1500 meter, but it says second half parallel pipe is connected in second half of the depth. So 1500 divided by 2, that means 750 meter, and its diameter is of same diameter, that is 0.6 meter. So RAB we can calculate, RBD and RBC we can calculate. Length of AB, let me show in figure. So length of AB is 1500 divided by 2, 750, and BC is also 750, and this is also 750. There says second half, so one half is 750 and another half is 750. So length is 750 in all the case, and diameter is diameter of this pipe is 0.6, and another pipe diameter is also 0.6, so 0.6 in all case, and frictional factor is 0.04 in all case. So RAB is equal to RBD, which is also equal to RBC, that is 31.878. So equivalent for pipe this BC and BD is given by this formula. So R equivalent we got 7.97. So head loss is head loss in AB plus head loss in this equivalent. So head loss in AB plus head loss in this equivalent pipe is total head loss. So H of AB is given by RAB times Q2 square, and H of equivalent is given by REQ times Q2 square. Q2 is discharge. So HF is 0.3 minus 0, that is 0.3, and RAB and R equivalent we have already calculated, so we can find value of Q2 0.0868 meter cube per second. Increase in discharge is Q2 minus Q1. Q2 is bigger, so it is 0.0868 minus Q1, that is smallest value, that is 0.0686, which gives 0.0182 meter cube per second. So in question we have asked increase in discharge, so increase in discharge we have calculated. So this is figure of second case. So thanks for watching. Like the video, share the video, and subscribe the channel.